move into, we're going to move away from isosceles, and now we're going to get into equiangular and equilateral triangles. And we've got two corollaries that need to go into your electronic notebook. I'll try and find the pictures for the hypothesis and conclusion, but you just go ahead and type the corollary itself to get it going. And the first corollary says, if a triangle is equilateral, in other words, all of its sides are equal, then all the angles have to be equal as well. So it's also equiangular. So if you have an equilateral triangle, it is an equiangular triangle as well, okay? And the opposite is true, okay? If a triangle is equiangular, then it is an equilateral triangle. So you really, they work both ways. So if you know all three angles are equal, then it's an equilateral triangle. If you know all three sides are equal, then all three angles are equal. It's really neat, okay? Now let's apply some algebra. So they want us in letter A to find x, okay? They want us to figure out what is x in that particular context. And they're saying that angle C is 3x plus 15 degrees. Now let's use this corollary. This is an equilateral triangle. That means all the angles are equal. So let's go one step further. What is the only angle measure that an equiangular triangle could have? Think about it. Equiangular, that means all the angles have to be 60 degrees. So this is going to be our math problem. We're going to do 3x plus 15. We already know what the total is. We know it's 60 degrees. We can rearrange this two-step equation and figure out what x is. Okay, so we've got 3x is equal to 45 divided by 3. So x is 15. And that's what they're looking for. What is x? X is 15 in this particular context. Okay? Now let's look at this one. Letter B, it says, okay, we got to find out what t is equal to. But all we know about the triangle is that all the angles are equal. Okay? Well, that's great, but the angles in this problem are not going to help us this time. Knowing that all the angles are 60 degrees, that's not useful. So we're going to use the other corollary that says, hey, if all the angles are equal, that means all the sides are equal. Look at that. So all the sides are equal. That means I can set JL, which is 2t plus 1, equal to KL, which is 4t minus 8. That's what that means. I can use that other corollary and go, hey, that means the sides are equal. So I can set the sides equal to each other. And then I can actually go about solving it. So that's the beauty of knowing these relationships. You can do this, okay? So let's take away 8, and now I've got, actually I should have added 8 to each side. So now I've got 9, 2t equals 9, divide each side by 2. So t is, in this case, 4.5, and there's my answer. So that's a little bit of how you can use some algebra with these two corollaries regarding the equiangular and equilateral triangles. If you have questions about that, please feel free to write those down and I'll help you. I'll see you in class tomorrow.